We've got an application question here where we're looking at the height of adult giraffes. So what I'd like you to do is whenever you have an application question or you're not quite sure what to do, we're just going to simply list what we know. So the first thing we know is that 5% of giraffes are more than 8 metres tall. So what I'm going to say is the probability that the giraffe is more than 8 metres tall is 0.05. That's 5%. Then it says 10% are less than 6 metres tall. So the probability that my giraffe height is less than 6 metres is 0.10. So that's the first bit of information I know. The next thing I'm going to think about is what my answer is going to look like. So here it says the mean and standard deviation is what I need to find. So I need to find my standard deviation and I need to find my mean. And that's what my answer is going to look like. And it's going to be to 2 decimal places. So I'll keep all of that information in my back pocket so that I could access it later. Now another piece of information we're going to need is all about standardised scores and z-scores. So remember, my standardised score is my actual score minus my mean over my standard deviation. And for a standardised score, then my mean equals 0 and my standard deviation equals 1. Now keep that in mind. This is for your standardised score, so they go together. This is talking about Z. It doesn't mean the mean of giraffe height is 0 and the standard deviation is 1. That would say the average giraffe height is 0 metres tall, which we all know, even although we're not on the safari, we all know that's just not true. So we're going to try and convert some information into this z-score equation, considering the information we already know. So the first question I'm going to ask myself is looking at this point here, so my data point where I have 0.05 probability, or 5% of giraffes are greater than 8 metres, I'm going to call that equation 1. And what I'm going to do is I'm going to ask myself, for these giraffes, let's write it down, greater than 8 metres tall, how many standard deviations is that away? So what I can say is, therefore, if I look at this, when I look at my standard deviation, I can say, therefore, what I'm asking is, how many standard deviations is a probability of Z being greater than 0.05. So here's my point here. So I'm going to call that A equals 0.05. And I'm going to put this into my standard equation on the calculator. So I'll go statistics, calc, inverse distribution, and I'm going to say I have my tail going to the right here, because remember, for these giraffes, if this is my bell curve, here is the point and there are 5% higher than that point. So my calculator, I'll say my tail setting is to the right. There's a probability of 5% or 0.05, and I find out that this is 1.645 standard deviations above the mean. So here, Z equals 1.645 when X equals 8. So that's my first bit of information that's really, really important that I know that. So I'm going to box that up. I'm going to do the same for this second data point here, or this second piece of information. And I'm going to say, okay, for giraffes that are less than 6 metres tall, I have 0.10, so a 10% chance that they're less than that. So if I'm going to draw their curve, that'll look like this. There's going to be a point here that's 6 metres, and I'm going to get 10% of my data. And I want to know what is my Z-score, so what is my standardised score when x equals 6. So in my calculator, I'm going to now set my tail to the left because I'm moving to the left. My probability is now 0.10. My standard deviation and my mean are the same. And I find out that this z-score is negative 1.282. So I'm going to write negative 1.282. So here is my information for the second point. You might be able to see what's going to happen here now. We're going to use these two pieces of information and this equation to make a set of simultaneous equations. So from my first one, I can say, when I substitute the values in here, 1.645 equals x, which is 8, minus the mean over the standard deviation. And from the second equation, I can say negative 1.282 is 6 minus the mean over the standard deviation. So now let's number them as all good mathematicians would do. So this is equation 3, this is equation 4, and we're going to set up some simultaneous equations. So I'll hit keyboard and I will go to my simultaneous equations button and I'll start writing in my information. Remember, it's always nicer if you use your proper fraction button, and you might also want to keep in mind, just for the calculator, that I'm going to use x for mu and I'm going to use y for standard deviation. I'm putting that in a think bubble so that I can keep that in mind without the examiner wondering what the hell's going on. So I'll write 8 minus x over y for that one, and then I'll say negative 1.282 equals, here's my fraction, 6 minus x over y, and I want to solve for x and y. So that's how to use my simultaneous equations, and I get that x is 6.87, so therefore I'll solve that. I'll do it over here. So therefore my mean is 6.88 and my standard deviation is 0.68. I've added them both to 2 decimal places, and hey presto, apart from the colour, my answer looks exactly the way I want it to. And it receives rapturous applause and much happiness from an examiner.